In this video we are going to solve the following problem. In 1998, 200 bears were introduced to a large island off Alaska where previously there were no bears. The population increased exponentially according to b of t equals b0 times a to the power t, where a is a constant and t is the time in years since the introduction. We want to find b0, we want to find a with the information given that in 2000 there were 242 bears, and we should interpret our answer. We should find the expected bear population in 2018 and the percentage increase in population from 2008 to 2018. And then we should find out how long it will take for the population to reach 2000. Okay, let's start with an exponential model. I wrote down the general equation of an exponential model. It's f of x equals c times a to the power x, and they told us that in this problem we should use b of t equals b0 times a to the power t. So just to make sure that we understand everything, obviously the b corresponds to the f, the t corresponds to the x, this b0, that will be the parameter c, and the a is the same, and the x is called t here. So it's just using different names for the variables. Okay, our first task will be to find b0. We know that c or b0 is always the initial value. And in this case they told us that the initial value was 200 bears that were introduced in 1998. So in this case it's just 200. Next one, so this was a. Next question is that we should find a with the information that in 2000 there were 242 bears. So for the year 2000 we will have to find out what's the correct value of t, because t denotes the time in years since the introduction. So the introduction was in 1998, so in the year 2000 t equals 2, and by this time the number of bears equals 242, so b of 2 equals 242. We can build an equation from that, because we can say that 242 equals, we know that b0 equals 200 times, we don't know a, but we know t because t is 2 in this case, so we get an equation, and we can solve this equation by dividing by 200. We get 242 divided by 200 equals a squared. We want a, so we take the square root. The square root of this one is square root of 242 divided by 200 is a, and that's equal to, or at least approximately equal to, let's use our calculator. We want, no, we don't want this one, we want a square root of a fraction 242 divided by 200. Oh, that's exactly equal to 1.1. Yes, of course, because it was the double of 121. Now we have a, and we should interpret our answer. If we have a equals 1.1, then it means that we have an increase because it's greater than 1. Okay, we already knew that the population was increasing, but now we have this number for it, and if it's the reproduction factor is 1.1, then it means it is an increase by 10%, because you remember that if it's 1.1, then it's 10% increase. If it would be 1.2, it would be 20% increase. If it's 1.02, then it would be only 2% increase, and so on. So it is an increase by 10% per year, because the reproduction factor gives you the increase rate, the reproduction rate per time unit, and our time unit are years. Okay. Next one, we should find the expected bear population in 2018. So we want to find the year 2018. This corresponds to t equals 20, because the initial point was in the year 1998. So it's 20 years after the introduction. So we have t equals 20, and we want to find out b of 20. We have just to plug in, because now we know everything that we need. We know b0, that's 200, times a equals 1.1 to the power 20. So it's just 200 times 1.1 to the power 20. Oh, that's a lot. If we round it to the nearest whole number, because there cannot be half of a bear, so let's round it down to 1,345 bears. Good. And next one, we should find the expected percentage increase. So between 2008 and 2018. So we need the population in the year 2008. It was b of 10, because 2008 was 10 years after 1998. That's 200 times 1.1 to the power 10. And we want to compare it to 2018. We know that b of 20 equals 1,345. That was the result from before. Let's just calculate this one. 200 times 1.1 to the power 10. That's 519. And we want the percentage increase. We should know the formula for the percentage increase for the relative change. This was delta b in this case, because it's bears, over the value at the beginning. So the value b of 0 in this case, and that's the increase from no, not b of 0, but b of 10, because we want to start in the time interval 10. Sorry, let me write it again. It was delta b over b of the beginning point. It was 10 years, so we have to divide the difference. We can calculate it by 1,345 minus 519, and we divide it by 519. Let's do that. If you type it into a calculator, don't forget the brackets. 1,345 minus 519 divided by 519. That's 1.59. And if we want to interpret this, this was a percentage change. So if it's 1.59, then it means that it's a 159% increase. Within these 10 years, so it was more than doubling, because doubling the number would mean an increase by 100%, and it was even more than that. We can check it. Yes, it's more than doubling the number. Okay, and last one, how long it will take the population to reach 2000. So we want to know b of t should be equal to 2000, and we want to know the t. So the equation will be 2000 equals b0, that was 200, times we know a, that's 1.1, to the power t. We don't know t. How can we solve that? Okay, let's at first divide by 200. That's easy. 2000 divided by 200, that's just 10. 10 equals 1.1 to the power t. And now we have to use something that can help us bringing the t down, and the solution for this will be the logarithm. If you remember the logarithm, there was a rule for the logarithm. The logarithm of, let's say, to use different letters, the logarithm of x to the power n will be equal to n times the logarithm of x. That was one of the rules that we used for logarithms. It will actually be the only rule of logarithms that we will have to use when solving equations. So you should memorize this rule. So we are now applying the logarithm. So we got the logarithm of 10 equals the logarithm of this one. Up to now, nothing special has happened, but now we can apply this special rule. The logarithm of 10 equals now t times the logarithm of 1.1. And we want t, so we divide by the logarithm of 1.1. And we got logarithm of 10 divided by the logarithm of 1.1 equals t. Please don't try to kind of cancel out the logarithms here. That's not a multiplication where you could cancel something, but that's two functions, two logarithm functions. By the way, it doesn't matter which logarithm you take. Oh, sorry. You cannot really see all of this rule. I'm very sorry. So the rule was logarithm of x to the power n equals n times the logarithm of x. This is the rule that we applied. It actually doesn't matter which logarithm you take, because any logarithm, so the base of the logarithm doesn't matter. Any logarithm will yield the same result if you apply it like this. So if we want to calculate this, we could just use any logarithm, for instance the 10 logarithm, or any else logarithm. So let's use the 10 logarithm, logarithm of 10 divided by, now we have to use the same logarithm again, the 10 logarithm of 1.1, and that's 24.2, and we want to know which year this is. We started in 1998, so this corresponds to the year 1998. So we had 20 years in 2018 and 4 more years, so it will be in the year 2022. If you don't like this logarithm stuff, then you could also use just the solve function of your calculator. So you could use, where is it? Here is it, here it is. We have the solve function of our calculator. We want to solve the equation 2000 equals 200 times 1.1 to the power t, and we want to solve for the variable t, so we use just a comma and t, and we get the same solution as above. So our calculator can solve this kind of equations for us. This is how you can solve the equation by hand.